Hi everyone. Today I'm going to review a few math concepts with you, starting with scientific notation. So scientific notation, if I choose to report a number using scientific notation, it's usually because I have either a really large number or a really small number. So for example, this 3,500,000, this would be considered a very large number. So you can see we can rewrite it to be displayed as 3.5 times 10 to the 6. And the part that I wanted to point out is for standard scientific notation, the first part, which is what we call the coefficient, should be greater than 1 and less than 10. Another concept for review is something called dimensional analysis. So dimensional analysis, this is when we're analyzing dimensions. We are trying to convert from one unit to another by this type of process. But before I get to review of Algebra 1, just to kind of explain this part here, let's say I was asked to convert 0.106 ppm to ppb. So ppm, this stands for parts per million, and then ppb stands for parts per billion. So you should know that just parts per million in general, that means you have one part in 1 million. And you can write that almost like a conversion factor type of thing. So if I wanted to convert 0.106 parts per million, I can rewrite it as a conversion factor. I can rewrite it as 0.106 parts per, so per means divided by 1 million. And if I want to convert it now to parts per billion, I could set up another conversion factor where there are 100 million, there is 100 million in 1 billion. And then if I'm looking at my units, it looks like my units in terms of million will cancel out. So if I'm looking at the numbers part, just looking at what I would punch into the calculator, I would take 0.106 and multiply it by 100 to get 10.6. And then if I wanted to also include my units, looking at what's left over, what I didn't cross out, is parts in the numerator section and billion in the denominator section. So right here, you can see part in the numerator section and billion in the denominator section, separated by a slash. And instead of saying parts per billion or parts and then slash billion, you would now see that unit written as ppb. So that's going to be discussed more when we talk about pollution with parts per million and parts per billion. But for now, just to review Algebra 1, looking at dimensional analysis in general, if I had example A, right, looking at example A with you, if I had this particular math problem, right, all these are variables. If I were to ask you, what does this equal to? You would say, all right, A maybe cancels out with A, P cancels out with P, E cancels out with E, nothing cancels out with S, so the answer would be S. Another thing that you could do with dimensional analysis is you could do almost like a reverse canceling out. So for example, number 2, if I started with a fraction, so right here I start with a fraction versus not starting with a fraction in example 1. If I start with a fraction, I could do reverse cancel, meaning this P cancels out with this P. This E cancels out with this E. And then if I'm looking at what's left over, A does not cancel out, S does not cancel out. So my final answer would be A divided by S. So these could be units. This could be like grams per mole. This could be parts per million, something like that. And then another way of showing work using dimensional analysis is something called the train track method. So if you learned this in a previous class, feel free to use that method. It's not a problem.